All right, guys, this AP practice problem, like I said before, this may not be the stuff that we've been working on. This is back chapter 14 with reaction rates, which is at the beginning, or at least like several months ago for the AP, start of the AP class. So let's take a look at this. It says the iodide ion, I minus, is oxidized to hypoiodide ion, IO, with a minus, but by a hypochlorite, ClO, with a minus, in a basic solution according to the equation above. 3 initial rate experiments were conducted. The results are shown in the following table. Now, we've seen this kind of problem before. We're looking for the reaction order with respect to both I and ClO, I minus and ClO minus. So let's take a look at the first one. The first one we're looking at, or I should do this. There we go. Notice that if I'm looking at, for I minus, let me get to a highlighter here. If I'm looking for the reaction rate of I minus, that means I need to keep these two the same so that the Cl I minus does not change in concentration, which means it would not change the initial rate. So we're going to do these two here, and we're going to do these two here. So this right over here is the rate, here's the rate, okay, and here is my I minus concentration. So I'm going to do, I typically do the larger number on top. For both of these, that's the rate of experiment number 2. So for I, if I'm finding I minus, I'm going to do rate 2 over rate 1, and that's going to equal, then I don't have to worry about the ClI, so I can just go right into the concentration of I minus is going to be, for 2, is 0.0, oops, I should write this part out first and then show you how to do it, of I minus, like this, 2 over the concentration of I minus 1, and all of that is to the n power, because we're not sure what that is yet. So when I start to plug in the numbers, I get 0.476 divided by 0.156. That equals 3.05. I got this one, obviously, is right there. This one is right there. And then that's what it equals, and that's going to equal, and then the other one I have is the rate number 2. So rate number 2 is 0.052 divided by 0.017, like that. And that equals about 3.1. So, and that is to, of course, the n power. So if I got 3.1 to the n power, that means that, and I'm only going to be 0, 1, and 2 as what n equals. And in this case, it's obvious that n equals 1 because they are almost exactly the same. So that means that I minus is first order. Excellent. Let's do the same thing, but in this case, let's reverse it so that we can find what we got here for ClO, which means I need to pick 2 experiments where ClO is basically the same, so we can ignore them like that. And I got 0.015 and 0.061, and that will give me a rate of that and a rate of that. Okay, so we're going to do the same thing. This is I2 here. ClO minus, we're finding, so that means the rate of 3 over the rate of 1 is going to equal, I'm going to scroll up so I have a little bit more room. There we go. It is going to equal the concentration of ClO minus 3 over the concentration of ClO minus 1. Okay, so when I plug the numbers in, but that's all going to be to the power of m. So let's, the rates, 0.596, that is rate 3. The rate of 1 is 156. Okay, that equals the concentration, 0.061, over the concentration, 0.015, like that, all to the m power. Let's continue on down. There we go. Looks like this is going to be, the rate is at 3.82 is what I get when I divide these two. I get, what is that, 4.06, like that. Okay, but that's to the m power. That gives me an m close enough to 1. These are a little bit far apart, but we know that if we, if I take, it's close enough. It's close enough, so which means that this is going to be first order also. First order. So, all right, I'm going to stop there, and then we'll handle B for the next part.